In order to introduce anonymous functions, let's consider functions that can be defined with a single expression. For instance, sine of 3.7x. Here's one a little more complicated. It has two arguments, and the actual mathematical form appears more complicated. And lastly, here's one with three input arguments, and it's not simply a call to a mathematical function, but it's a call to an existing function, my function, and the input arguments of h are mixed up and jumbled around to become the input arguments of my function. Nevertheless, all three of these are defined with a single expression. Suppose we need to work with functions of this form. For instance, numerically integrate or differentiate, find the zeros, minimize, any one of the ideas that we brought forward when we introduced the function handle and the notion of an algorithm that might act on a function. We always have the option of writing a simple M file for this. Function declaration line, and then the one line which is this expression. But these are so simple, you wonder if there's some way we can avoid storing such a simple function in a file. Rather than opening the editor, creating a file, saving it, is there another option? And there is, and it's called anonymous functions. When an anonymous function is created, Matlab stores the single line expression somewhere, hence we'll call it anonymous. And for us, the creators, Matlab returns a function handle to this newly created anonymous function. Let's see exactly how this is done. You create an anonymous function using the following syntax. Begin with the @ sign and a parentheses enclosing an input argument list, and then the expression which constitutes the anonymous function. The return value, h, is a handle to the newly created anonymous function. Let's do this on a simple example. In this case, the input argument list is a single input argument. Here, the letter x is used. Then the expression, which depends on the input argument, is 3.7 times sine of x. That defines the function in terms of its single input argument. In this example, x is a dummy variable and can be replaced by any legal variable name. This assignment both creates an anonymous function and returns a handle to that function. As h1 is a function handle, use h1 to reference the function, here creating a 1×3 row vector of 0, 3.7, 0. The expression can involve variables whose value is fixed. For variables that are in the expression but not in the input argument list, the values of the variables when the anonymous function is created are used. In this example, the input argument list consists of a single argument Fred as opposed to a single argument x, and the expression has sign of that input argument. In the earlier example, we used the number 3.7. Here, it's a variable m, but m's value when the anonymous function is created is 3.7. Therefore, the behavior of these two anonymous functions is exactly identical. This produces exactly the same row vector. If m is changed to 4.7, that has no effect on h2. The value of m was important when h2 was created. So in this instance, h2 will still evaluate to the exact same row vector. Let's try this in Matlab. Let's start, as we did in the slides, creating an anonymous function using the expression 3.7 times sine. The class of this variable h1 is a function handle, and this function evaluates as expected, giving 0, 3.7, and 0. Rather than building the anonymous function with the number 3.7 explicitly shown, we can do that with a variable whose value is 3.7. Now make up the anonymous function like this. The dummy variable is switched from x to y, but it's still just that, a dummy variable. The expression is given in terms of the input arguments. And here, the value of m, when the anonymous function is created, is what's used. So the anonymous function created here has exactly the same behavior as that created earlier. Let's check that out. We see that the function evaluation is the same. If m is changed, that has no effect on the existing anonymous function, since only the value of m when the anonymous function was created is what's important. h2 has the number 3.7 in it. If the anonymous function is rebuilt, now the new value of m is used, 4.7, and we should see that reflected in a calculation.